Welcome to EDU World Space.
So in this question, we are given a cube of aluminium, right? Cube of aluminium, right? And its elasticity is given to us, that is 10 into 10 raised to power 3 KSI, and its epsilon, that is equal to 0.33, right? And we are required to determine the principal strains, right? So these principal strains are epsilon sub x, right? Epsilon sub y and epsilon sub z. Right. So let's start with the solution. Solution is very simple. When you look at the given figure, right? Uh, we from this system of x's, right? In the figure, we get that the stress in the x direction is equal to 10, the stress in the y direction is equal to negative 15, and the stress in z direction is equal to negative 26, right? So let's start with the solution. Now, first of all, what we are going to do is that we are going to use the Hooke's law, right? And we will use it first of all for x direction. We'll make the equation for x direction, right? So we need to find out the principal strain in the x direction, right? Now 1 over elasticity, it remains the same for all three equation, right? It will remain the same. Square bracket starts, right? Since we are doing it for x direction, right? So the stress for x direction, right? The stress for the x direction will be at the start of the square bracket, right? Next, we have negative epsilon and closed parenthesis, right? Now, since we are doing it for the x direction, right? For the x direction, so it means that the stress for the x direction will be at the start of the square bracket, and the rest of the stresses will be inside this closed parenthesis, right? So it means that over here we will have stress for the y direction plus stress for the z direction, right? It's very simple. Now that the now so that the procedure for making these equation is out of the way, we can jump to um, solving this question, right? So now we have this equation, we just need to plug in the values. So epsilon sub x is equal to 1 divided by 10 into 10 raised to power 3, right? The stress for the x direction is 10, positive 10, negative 0.33, parenthesis starts, negative 15, negative 26, right? Parenthesis close, square bracket closes. When you calculate it, you'll get that it is equal to 0.002353. That is approximately equal to 2.35 into 10 raised to power negative 3, right? This is the solution for x direction. Now let's move forward to y direction, right? So for y direction, the equation would be the strain for the y direction. 1 over e remains the same. Now again, we are doing it for the y direction. So the stress for the y direction will be at the start of this equation, negative epsilon, close parenthesis. So in these close parentheses will be the stresses for the sum of the stresses of x direction and z direction, right? So now we have the equation. Just plug in the values, right? So we have 1 divided by 10 into 10 raised to power 3. Right over here we have negative 15, negative 0.33 into 10 negative 26, 10 negative 26, right? Just calculate it and we'll get that the strain for y direction is equal to negative 9.7199 into 10 raised to power negative 4, and that is approximately equal to negative 0.972 to 10 raised to power negative 3, right? And this is the solution for part B. You can say part B, right? Because that is for the y direction. And now we just need to find out the solution for part C, that is the z direction, right? Now, first of all, we need to make the equation. So we have the strain for the z direction. 1 over e remains the same, square bracket. We are doing what the z direction. So the stress for the z direction will be at the start of the square bracket, negative epsilon, close parenthesis. Um, Stresses for x direction plus stress for the y direction. We have the equation, just plug in the values. So 1 divided by 10 into 10 raised to power 3, negative 26, negative 0.33, 10, negative 15, right? So calculate it and we'll get that it is equal to 0.002435. That is approximately equal to negative 2.44 into 10 raised to power negative 3, right? So this concludes our answer for part C, and for all